Hello everyone. In this class, we'll be seeing about software performance analysis. This comes under third unit of your embedded and real-time systems. Now, the topic for today's webinar is program level performance analysis. Now, what is this all about is we'll be studying about estimating the run times of programs. So that's pretty important for embedded systems, and also how we can optimize the programs to improve their execution times. That's also a very good discussion. Then CPU performance as such is not judged in the same way as program performance. People tell that increase the clock rate, you can do it, measure the performance by using CPU clock rate. But CPU clock rate is unreliable metric. So we can include CPU pipeline or cache, which can act as windows into a program. So to understand about the execution time of our program, this particular diagram is shown here. So this is the cache memory whereby some time is taken to access the data uh, because of access time that is shown here, and then this is to be retrieved, this is to be written. All these things are possible here, and then the pipeline diagram is shown here, total execution time, and then if there is something called a loop, a conditional loop, it branches out and comes back here. So this particular diagram helps us to understand things about the execution time for a typical program. Now, so as we have seen in our particular diagram, pipeline, caches and loops, so they account for that execution time. It all depends upon the instruction level also. So if it's going to be your RISC or CISC or complex instructions, all those things, it's going to matter a lot. And also if you're going to operate on simple data, or it's going to be floating point operations, so that is also determine a lot on these particular time, execution time. So that is of again an important example. And then over here, Microsoft processor manufacturers supply simulators, so using which you can measure accurately the CPU performance, uh, the execution time of the program, that is can be accurately measured. So how it could be done is you can make use of a timer by measuring the start and stop of the program, and then we can make use of a logical analyzer of physically, whereby you can take out from the pins of the processor, use a logic analyzer to measure the start and stop of the time of the execution of the program. So the average performance metrics of a particular program, I can say it comprises of average case execution time, that's a normal thing. Then the worst case, the maximum time it takes, or the best case, so minimum time it takes. So these are the three typical things that looks with the program performance metrics.